as you were the coordinator sort of between Positron and these our guests today.
Right. So just wanted to say thanks for your all participation on this webinar today. As much as anything else, I wanted to do 2 things in terms of the intro. One, I just want to make sure that, the folks that are on the call from the utilities, I just want to advise you that I think we're still in the quiet period for the RDOF. So we want to refrain from any specific details with respect to, the RDOF auction. So that's item number 1. And then item number 2 is really just wanted to get your all's feedback on this technology as much as anything else. Folks from Positron have approached UTC, and I, was interested in their technology in the sense that it does help to support the kind of speeds that utilities are offering in terms of broadband, and then 2, may be able to bring our costs down. So from that, let me go ahead and just turn it over to the folks from Positron. We can go ahead and, go through the presentation and open it up for Q&A.
Okay. Sandra, I don't see everyone. Is that the way it works, or I should be able to see every? Oh, now I see it. Okay, now I can see. Good.
Yeah, if you click on the participants on the top, on the bottom.
Oh, good. I see Pierre.
Should we do like a quick roundtable of everyone who's here? So we have from from United Electric Co-ops. Maybe you want to introduce yourself.
Hey, I'm Darren Farnan. I'm the Chief Development Officer here at United. On the UTC Broadband Committee, obviously, work with Brett. Lee's on there as well, but she'll be introduced himself. And then we also have TJ Plumley on. He's one of our field he's our field service manager. And we've actually ordered some of the Positron equipment in. We're still in the testing phase right now, just kind of in our knock. So we're just looking at it, but we've really opened up a lot of MDU properties over the course of the last 6 to 12 months. And so it would be a big benefit for us in those type of markets, especially.
Perfect. Thank you. From Mid Carolina Electric Co-op, Lee.
Good afternoon, folks. Thanks for inviting us. I'm Lee Ayers with Mid Carolina Electric Co-op. I'm Vice President of Engineering. And what really intrigued me was that an MDU solution. We're very close to getting started trying to service some MDUs and have really been scratching our heads. So hopefully we're going to find out some really enlightening information today.
Okay, great. Then the last utility is Douglas Fastnet. So Todd or John?
My name is John Brainberg. I'm the Chief Information Officer for Douglas Fastnet. We're a wholly owned subsidiary of Douglas Electric Cooperative. And we're serving primarily Oregon area. We currently have quite a few deployments, both standard, fiber to the home and some MDU. We don't have a lot of large MDUs in our area, but always looking for technologies to be able to do that in a more cost-effective way.
Okay, perfect. So from Positron, there's myself, Mr. Weiser, and Pierre, do you want to say a couple words? Pierre and Peter?
Yeah, thank you, Sandra. So Pierre Trudeau, I'm the president and CTO of Positron. So Well Reg will do the main introduction to the solution. I'll be there to answer any more detailed questions you may have, and I'll take you through a few slides to just cover how we are fitting into RDOF. We understand of the quiet period, so if you feel you cannot answer questions I may bring, just say so, and we'll just share what we have presented to other parties like you that have taken part in RDOF and how they can expand the toolbox to serve the living units in the different census blocks where you're getting RDOF money.
So I'm going to explain at a high level what it is that we do and why we develop the product. And Pierre will go into more technical depth as needed, and Pierre will completely take over the presentation as we get to RDOF. But essentially, what we did is we came up with a unique methodology. It's a part of an ITU standard, but it's far more robust than the technology, the BDSL2 technology that enables us to be able to get gigabit speeds over telephone pairs at long distances and also over coax. there was a technology that was of interest to people before called G.fast. That technology had its limitations, and it didn't have all the noise cancellation capabilities and stuff in the software that we have here, that with vector boost and cancellation, that makes this possible. And people didn't really believe it was feasible. And that's why we offer free units to try, free trial units and so forth. Essentially, before going into some of the different areas, just a little background on us. We've been around for 50 years. We've been, as you can see, we've been very active, and we've been dealing with many carriers for many, many years. We have 220 telecom customers, like carriers, and we have a number of distributors. And we've been working for a long time with Luminum, as they're now called, for many, many years. Windstream, Verizon. These are some of the companies that we're dealing with. And this is a product that is physically working in the field over coaxial and over copper pairs. We've got satisfied customers, a lot of references. And I thought to first, before going into what we're doing, that to give you an idea, so before going into the product, this is what G.fast did a while back, or was supposed to do. It hasn't really done it very effectively at this curve. This axis is the speed. Like we start off at something like 1.7 gig, and we decrease as we go further in distance in terms of the bandwidth offered. So to give you an idea, on a single pair over here, we can deliver a gigabit. This is 1 gigabit at 500 feet. In most places, you have 2 pairs. So with 2 pair, we can go 820 feet. And if you go further out to say to this distance over here, which is about 2,300 feet on copper pairs, will still give you 200 megabits, and we're talking virtually symmetrical bandwidth. That's over copper pair. By the way, you can feel free to ask questions anytime as we're going along. This is how we perform over coax. This is the inexpensive type of coax that you get in hardware stores. This is 1 gigabit. You'll get it at about 1,000 feet. And if you use a type of like RG6, which is what you normally find in buildings, we effectively will give you that at 2,600 feet. So this is very, and this gives you an idea of the technologies, the competitive technologies that are out there. G.fast was the great wonder that hasn't really worked very well with carriers and had its limitations and interference. It was more costly, and also didn't give you the bandwidth. DOCSIS, this is cable technology with the using coax kind of thing. And there you have a problem in the sense that you can't get very good upstream, like 200 megabits, you can't get symmetrical, and it's also much more costly than us. Our product, this is what our product is the GAM, which is gigabit access. Obviously, the best way to go is fiber. Whenever you can go fiber, you can always get more. You can get 10 gig than that. And so if you're building a new structure, if you're going to a new building, if you're doing in-building wiring, you obviously should go fiber right at the start. Most buildings, like 90% of them, are older than 10, 15 years, and so they have either copper or coax or both, and it's very expensive to change it. So we came in, and we can basically, if you can bring fiber, bring fiber to the building, or fixed wireless bandwidth to the building, or it could be a distance away from the building, we'll deliver it the rest of the distance to give you a gigabit to each subscriber, saving substantially on dollars. This shows you how it just hooks up. These are an example of some 24-port units. There's a coax unit, and this is a telephone pair unit. Each port would be could give you 1 or 2 pairs as per subscriber, and we input over here with an SFP, either they're directly from the fiber input, like they're two 10 gig ports in the units, or this could also be a fixed wireless feed. And essentially we go the full distance over the copper pairs or over the coax to the residential gateway. And this is a unit the size of a deck of playing cards. It just does a conversion back to gigabit Ethernet. When you're going coax, we're able to use all the existing splitters. You can get up to 16 splitters per subscriber. So essentially, what we're doing, and giving this high-level view, is if you can deliver the bandwidth at the building or near the building or home, then we can get you the rest of the way over the existing wiring, and you can save substantially on the dollars. It's compatible with all of the residential gateways. It's a completely non-blocking thing, and we're giving you symmetrical bandwidth because it has dynamic bandwidth allocation. So it puts the bandwidth where it wants, and it instantly, if there's higher demand upstream, it goes more upstream. Downstream, it does that triage. But if you did a speed test on it, you'll see we're basically a gigabit upstream and downstream. You can assign the bandwidths that you want to the customer remotely, or you can give them the ability to self-register, and the product has all the most advanced features that carriers want, from quality of service, every kind of troubleshooting, guaranteed bandwidth, and so forth. This gives you an idea of the product range, which I'm going very quickly. These are the indoor units that you put. These are 12 and 24 port units. These are the little modules that fit before the residential gateway, and these are outdoor units. These are IP67 enclosures that could withstand the temperature. We have them in coax, or we have them for telephone pairs, 4 or 8 port units. And when you're a distance away, you can either work from local power, or we can do reverse power feed from the homes, so you don't have to install local power to the units. To give you an idea over here, here's some buildings where basically wherever you have your fixed wireless or your cable input, you can if you bring it to our units, and you can daisy chain these units, you can add more units together, you can get to every place very, very effectively. This is an idea of an outdoor unit. This outdoor unit doesn't have to be here. This could be way back here at a fiber junction point, and it can go to individual homes or little clusters like this. And each subscriber provides, if we use the reverse power feed option, provides their portion of the power, and it works even if you only have one subscriber connected or more subscribers, so you don't have to worry about the power. This shows you how it works with coax, because a 4-port unit can, if you have coax, can serve, if you use 16 splitters, 64 ports. This gives you an idea of how you can do home clusters. When you have home clusters or things of this nature, if you have fiber along a roadway or anything else, we can go to a fiber junction point, and we can get to each and every house effectively over the existing copper, and give you the full bandwidth capability. This is what the inside of the unit looks like, typical home clusters or something. This is one with reverse power feed. And the other thing is, these units could be daisy chained, in the sense that if you go to one home where you put a unit over here, you can use 2 pair to daisy chain to the next unit, so each unit will then, if you're consuming 2 pairs in and 2 pairs out, each unit will still have 4 subscribers in an area, and you can stretch this out 800 feet and still get a gigabit before further distance you go down. So it's a very effective way. this gives you an idea. If you want to let the people pick their own bandwidth, you can give them screens like this. And I'm going to let Pierre take over at this point. I'll just go that effectively, there's nothing that can come close to this. The cable thing and fixed wireless, 5G doesn't penetrate buildings, so anything you need to be able to distribute it, and we enable the distribution. And with our dynamic bandwidth allocation and vector boost and so forth, we can guarantee that you're not going to get crosstalk or anything. And we also provide the highest level of carrier capabilities. To go a step further, as an idea, we've seen costs as high as $600 to $800 if you're talking about deploying in buildings, which have older buildings with all kinds of full fiber trays, but they come in various sizes. This is by far the most cost-effective way to do it. You can do it for businesses or residential units or home clusters, and you use just the existing wiring. So the main thing is that you can, with this, effectively, and Pierre could describe if you were interested more in learning about our management system, you can effectively get places up super fast. In other words, you can get buildings up in hours instead of doing all that construction work because you're using the existing wiring. It's also very scalable because you don't have to rewire. You're not going to fiber part of a building and then go back and fiber another part of it. So, and you only have to put in what you need. You can add with us as you need it. So there's a very small, we're roughly 20% of the cost of having to put fiber in. And this, so I've given you some of the background information, and you may have some questions on this. And then we would go right into more of an RDOF presentation. First of all, are there any questions? And then I would let Pierre take over. Do you understand the concept?
Any questions, folks?
I don't know, this is John. I don't know if we'll cover this a little bit later, so I don't want to jump in too early, but I was kind of curious on, does the management software for the head-end device support any sort of performance testing?
Yes, it does. So G.hn has a built-in NID function. It's a carrier Ethernet capable switch at the core of it. So we can do things like synthetic traffic insertion and loopbacks and so on. Other things you can do with Y1731, and it's a RFC 50. I'm just going back from the RFC, but the RFC does all of the loopbacks. So you can do performance management. And if you rely on NIDs, because a lot of our customers that have a fiber infrastructure rely on NIDs, you can take a baseline and then monitor. We have a MIP or a MEP function, so we can report latency and jitter functions, especially on the uplink, and you can determine if we deviate from whatever baseline you established up front, which could be caused for by all kind of devices. It may be our device, it could be any other device in the data path, so we can help you troubleshoot this before customers start complaining, for instance. So we have all of these things. And on the G.hn portion per se, where it's over coax or twisted pair, we have a built-in scope, kind of a spectrum analyzer, which lets you see things like noise and conditions, and if shorts are open, any physical fault in the wiring, any causes for noise or anything else that may create lower performance. So you can easily troubleshoot from a remote location before you send a tech on site to fix whatever may need to be fixed.
Okay, thank you. I guess next question also is, do we have to deploy with your product filters at the customer side, and especially if they're using voice?
No, we don't. So if we run on copper, G.hn starts at 5 megahertz and above, all the way to 200 megahertz. So we can cohabit with POTS. Reg, can you go back to the product slides when we have a picture of the products? So we have one of our endpoint devices a couple more. That so the device stop. So if you look at the device kind of near center, the one next to the second row of equipment from the left, it's something we call a G1001. That's a device that converts G.hn back to gigabit Ethernet. And in the front, so there we see the front. In the back is the gigabit Ethernet port. So on the front, the rightmost connector is G.hn and potentially POTS services of traditional telephony. And then we have a POTS splitter built into the device, and the middle connector would connect to your regular telephone wiring in the home for telephony services. And that works that if there's a power outage, for instance, the telephone service stays up. So for all of the 911 conditions are met in that case. We also, if you do voice over IP, then also there's no need for any of these POTS splitters. You just need an IP phone at the end of the day, or a CPE that has a FS0 output.
Sure, thank you.
Okay. And when we run on coax, the same thing applies. Normally, we don't run alongside DOCSIS, but we may see cable TV signals. So as long as the signals for the TV channels start above channel 23, we're good. There's no overlap, and we can run any number of analog or digital TV stations on the coax, use the standard decoders, and have the gigabit speeds on the same infrastructure. And one thing that I think Reg touched upon it briefly is when we run on coax, we don't have a limit of upstream bandwidth. Actually, the same applies on telephony, on telephone wiring. So we can have gigabit speeds uplink and downlink. We're not limited the way traditional DSL is or DOCSIS, where you have about 5 to 10 times more bandwidth downstream than upstream. In the case of G.hn, it dynamically balances out between upstream and downstream to match customer traffic. So like today we're doing Zoom sessions, so there's a lot of uplink, at least from Reg presenting right now, and it's okay. It just adjusts dynamically as required. So any other questions? Okay, so Reg, if you relinquish, if you give me the ability to share my screen, I'm
Yeah, I'm going to stop sharing and I'll let.
okay. So this is a presentation that we created early on when RDOF was officially announced last April timeframe it was, and that we've expanded a little bit over time based on discussions with other operators like you. We've had the discussions with from the very small, very regional operators all the way to the big tier 1 carriers, and presenting pretty much the same solution, where in this type of environment, you can have a fiber and or fixed wireless infrastructure as your main access network. But there's always a challenge to cover the last couple 100 feet. And this is where our solution can come in very efficiently in this type of lower density market. So we can do the very high density, large MDUs with hundreds of doors, but we can also do these remote suburbs or even purely rural type of environments. So I think we all know rural fiber and GPON is complex and expensive. And GPON is a great technology when you have a dense market. You can really reduce your fiber cost. You can cover a lot of, pass a lot of ohms and activate ohms easily. But when you have major distances between each of the households, that starts to fall down a little bit. It still works, but it creates a number of challenges. And then if you go fixed wireless, well, you have issues with foliage, with hills, and so you cannot go purely fiber, you cannot go purely fixed wireless. And in either case, you always have the issue that do you put a fiber drop all the way to inside the home? Do you put a fixed wireless receiver on the rooftop? Not everyone likes that. So we help you kind of get the best of all of these technologies and reuse the existing telephony or coax wiring already there to really serve your customers that much more efficiently. So we are really focused on the last few hundred feet, basically from the road to inside the home. That's really our segment where we focus. We don't reinvent the wheel with the main access, but what we help is our technology is sufficiently cost effective that we can even, in some cases, we have our customers pre-installing our devices because they are less than the truck roll that would be needed to activate to the customer. So we give some interesting options. And basically, we can even serve, whether it's a single family home or it can be a small cluster of homes, we can serve that from wherever the gigabit feed terminates. So just a different view of rate and reach. Reg had a first diagram. This is results that we took with a major tier 1 operator in their lab. And what we see is up to 800 feet, a little over 800 feet, no matter how many active pairs there are in the copper binder, so with all the crosstalk, we still deliver a gigabit speed. So those are speed test results. And if we have only a single active pair, we can go another 100 feet or so before it goes down. But we still have the ability that even at 1,000 feet and beyond, we deliver well above 500 megabits in both directions. So a lot of throughput, a lot more than some alternative technologies. And if we have a single pair, we're good to about 450 feet, and then it still at 1,000 feet on a single pair, we achieve roughly, again, 450 to 500 megabits per second. Whereas GFast was very limited, and the upstream, you could barely do a little over 100 meg at that distance. So a lot more flexibility, and it beats DOCSIS that, again, works well when you have fairly high dense areas. So that's the other device that we're building is we have a single port, we have a single port version of the device. The outside shell will actually be slightly different. This one was a proof of concept. It will be closer to the units that we have for our IP67 enclosure, but it's about the size of a outdoor ONT that you may have been deploying. But what's nice is it can take a GPON feed, and it's reverse powered from the home, and then we have, say, telephone pairs to the home. So we don't need any local power. So we are, in terms of the powering, we are a passive device. Your electric co-op, so you know how to bring power to any location, but there's still some work involved. So we're trying to help mitigate this as best we can. And we have then our 4 and 8 port outdoor devices that we covered briefly. So here's the picture. So what we have here, we're showing a active Ethernet feed, but we can take any SFP, SFP plus module. We're not keyed, so we can terminate any type of fiber, whether it's PON or active Ethernet. And in the cover is where we put our reverse power feeding circuitry. That means that from the home, from the subscriber, we can inject a 48 volt power feed that goes to the unit and then powers the main circuitry. And it works, it's like power over Ethernet, but the other way around. So it's the end device that powers the switch instead of traditional PoE. And we make sure that only those subscribers that provide power actually get a service. So that way it's fair, it's balanced, and everyone just contributes to powering their G.hn circuit and then evenly bring power to the main circuitry of the device. And what's important is if we look at whether we have 1 or 2 pairs, the powering scheme never limits our ability to deliver either a gigabit speed or 500 megabit speeds to the home. Whether we are on 1 pair, we can bring power to about 950 feet. So just shy of 1,000 feet, we have more than enough power to turn on a GAM device, where a 500 megabit feed would be about 800 feet away from the home. And then if we have 2 pairs, we can push a gig again at about 800 feet and 500 meg at 1,000 feet. But the power, having 2 pairs, we can go about 1,400 feet. So the powering scheme is extremely flexible. It eliminates the need for having power drops all over the place. And it speeds up the installation drastically. And it does not limit the ability to deliver the services at the typical distances. So when we've spoken to a lot of operators and shared numbers from industry and all that, and the cost for deploying fiber is about $20,000 per mile. And if you have 10 to 15 ohms per mile, so you have 1,300, 1,500 is the range for average cost of fiber, but very often we see in remote communities that the density is half of that, and therefore the cost per ohms goes way up, $2,500 to $4,000, and then is about another $600 to get to the front door of the home and another $250 to enter the home. So we're really focused on this $850, and it's important that we do the savings that we can bring here. Means there's more money to go with other fiber or fixed wireless infrastructure, because you all went through the bidding process and you bid at whatever price you could get away with. And while RDOF is fairly generous, it will not cover all of your costs in most cases. So our goal is to help you reduce the cost so that you can get a quicker quicker return on your initial investment, and then have more of the ARPU for those customers that you activate going to your bottom line. So we save on the CapEx, we save on the time savings, because we can avoid that second truck roll. Our equipment can easily be self-installed for the in-home portion. So with COVID now, people don't want to see any strangers in their homes, and your techs are probably not crazy entering homes either. We can help you do this, and it saves time when you don't have to send a tech a second time around after the main fiber build out or fixed wireless infrastructure was put in place. So if we look at what we call a micro GAM is a single port GAM. It's a product that we will be releasing shortly. And the way it connects here, we're showing a PON network. It could be an active fiber. It could be also fixed wireless that then connects into our device. Having a SFP ONT is great because we will provide power for that ONT. We don't need to power it separately. We have the microGAM installed wherever the fiber terminates. We leverage the existing copper into the pedestal along the road and then into the home. And we install our endpoint device that converts G.hn back to gigabit Ethernet, and then you put the Wi-Fi router of choice, whichever one you selected. So that's how we do it, a single home at a time. But what we see is sometimes you may have small clusters. So we have a 4-port version of the device where if we assume 200 feet roughly from the pedestal into the home on average, that means we could go 600 feet right, 600 feet on the left. So a span of at least 1,200 feet, and then serve the small number of homes, each with 1 or 2 pairs. So now that starts to become very cost effective because again, the GAM4 MRX is remotely powered. And with 1 fiber drop, you can serve this small cluster of 4 ohms. And if you go with something with a little bit more density, if you have 8 ohms, so maybe a larger lot was subdivided and a promoter came in and built some independent households. Now, again, you can go 1,200 feet left to right, assuming that on average you have this 200 feet into the home. That's if you really are pushing for a gigabit service up throughout the installation. If you're content with say a 500 meg service, you get a little bit less in terms of RDOF subsidies, but you still get a good chunk of assistance. Now you could extend this to be 1,000 feet to the left, 1,000 feet to the right. So you're starting now to get close to well above a kilometer. You're close to almost half a mile of stretch where you can cover homes like this. So suddenly it gives you a lot of flexibility on how you can cover it even more granular than the last mile, but the last few thousand feet of connectivity. So if we put all the pieces together, from wherever you would have a splitter, we can have a single home there, another cluster of homes on another fiber stretch. You may need to go a first split, let's say a 1-to-8 split, cover this segment. You go some fiber further out, you have another 1-to-8 split, and then you go this way. Because I'll say each time you split, you have some attenuation, so you have to be careful with your attenuation budget on fiber, but it gives you a lot of flexibility. And by reducing the density of splitters, you can go further out. Because here, a single split will serve a cluster of 8 ohms or 4 ohms instead of having a higher density or more aggressive split level that would constrain how far you can go with your fiber installation. Any questions at this point before I go into some of the cost analysis? Okay, so well, this is a very similar summary to what Reg provided, so I'll skip on this one. So usually where people start to ask more questions is, if I have a single family home, we take for granted that the if you're based on fiber, that the fiber along the road is a sunk cost, whether you you activate a home or not. It's there, it's part of your investment, and that's part of RDOF to cover these regions. So a number of $600 to bring fiber from the roadside all the way to the front door, it seems to be reasonably average. And then inside the home, there's about $250 worth of work, whether you go through the attic or put a hole through the wall or through the basement. It's about $250. The ONT all in is about $175. You don't need an Ethernet bridge the way we do for G.hn, but you have about $1,000 of investment. If we just worry about ohms passed, and we just install a micro GAM and connect it to you can connect it to the copper pairs, but you're not yet terminating the service. It's about $250 all in, because you have to terminate the SFP ONT, which is a bit more expensive than a standalone ONT, but easier to deploy and operate, and the microgam itself. So you save about 42%. But when you go and activate, what you need is to bring the same SFP, so it's the same duplicate cost of $175. You don't do any additional fiber. And the GAM bridge is about $99, so you're now saving about 56% versus a pure fiber approach. Where it gets really interesting is if we do a 4 ohm cluster. On the left side, it's the same cost because you have to have a fiber drop per door, so no changes. But now a micro GAM, a GAM4 has about a cost of $275 per port. But we share the cost of a single SFP ONT across all of those ports. So the 175 divided by 4 is about $45. And the savings starts going up. And then when you go into the home, you save about 60% of the total cost. The home, it's the same equipment you put either way in the home. So this gives you a lot of flexibility, because as soon as you have a first customer, it activates the GAM4 MRX and provides services to that customer. When the other customers connect to they just need to install our G1001 MR, so that's converts GAM back to Ethernet and installs the CPE. Then suddenly you have self-activation, no need for a second truck roll, and this customer will provide the power because we inject that on the pairs reaching that specific ohm, and you're good to go. And we had some discussions with, that's an area where obviously, Brett, you may have more visibility, but according to the FCC, there seems to be a consensus that the demarcation point is where the property line terminates, which usually means that it goes all the way to the rural road or to the county road, and whatever copper is on that land all the way into the home belongs to the homeowner or to the farmland owner, so anyone can use that copper, not just the ILEC that may have put it in whenever. So it gives a lot of flexibility on how you can complement your fixed access infrastructure, whether it is fixed wireless or fiber-based. Then if we do with an 8-port device, the same recipe, this time though the savings can easily exceed 65% per ohms passed and 70% for ohms activated. So those are hard to beat. And even if some of our people say, well, okay, well, it's not $600, it's $500 to bring fiber to the door, we're still significantly more cost effective. There's nothing that is more cost effective to date than using GAM. So that was a quick view of how we handle RDOF. Let me just bring it to this summary slide here. So any questions? I know I went fairly quickly. You may want to digest this, but we'd be happy to share the presentation with you and have any questions you may have, answer any questions you may have now or in the future.
Don't see any questions. Anybody? So I guess one abstract question I have is, to what extent have you all tried working with electric utilities to deploy this technology, either in the United States or in Canada?
We've done some work in the United States. We have worked with electrical co-ops with the Positron Power division that provides protection for high power issues. Safety. Reg can better describe it. It's not the part of the business I'm more familiar with.
Over 100 power utilities in the States, and basically the area of business has been to provide protection for communication circuits or isolation communication circuits coming in on wire lines into substations where we'll retransmit across an air gap for safety reasons. And we also have other products and other dealings with power utilities. Those products are sold either to power utilities or to telephone companies serving them. And so we have a lot of major power utility customers. But this is but this division, which is actually our biggest division, deals with providing broadband services. And so and what was so interesting here is we were mainly dealing with the power utilities on the power side, not so much on the broadband side. And so it's nice to know that you're branching out and filling in where the large carriers are really not doing that good a job.
So we've just started to engage with the power utility co-ops, and I'll say UEC has started to test our GAM device recently. So we starting to engage, but we see that I think there's a good fit, and we just want to get closer to the membership of the UTC because we think that we have a nice toolbox to complement what you're already doing with fiber in your network. Because fiber is great, but it's not the answer to every single challenge. So we help you get more out of your fiber, especially where fiber gets the really, really expensive portion of the fiber, the last few hundred feet. That's where we shine, really.
Gotcha. The only other question I had was just, okay, so if the devices are basically powered off of the coax or the twisted pair, does that present sort of a barrier when you're working with the utility? Because you're not lighting up the same line, right? I mean, so.
Well, they can be locally powered as well.
Okay.
Even the outdoor version can be locally powered if there is an AC or DC feed easily accessible. I guess the remote powering message is mostly for the non-electric utilities, the smaller ISPs, LECs that have to pay someone to bring power to that location.
Gotcha.
In your case, if you have an easy access to the power, then all of our devices that are reversed powered can also come in a configuration that is locally powered. And all we need is a 48 volt DC source. So that's easy for us to operate one way or the other.
We have significant reference that we can give you tons of references and customer stories and so forth, and the performance is rock solid, irrespective of whether we use our telephone pair version or our coax version of product, and we'd be very happy to let you try it.
Okay.
Are each of you involved in RDOF, or only some of you are involved in RDOF and others are using it for other applications, or potentially using it for other applications?
I don't think we can really speak to that, but I will say that we have applications that would be usable for rural applications.
Right, because obviously this rural, the diagram that I have on my screen now is not limited to RDOF. There is a challenge outside of RDOF subsidized areas where you need to put more bandwidth, and right now you're challenged. We're actually working with a large tier one that wants to have a hybrid fixed wireless and G.hn solution over their existing copper outside plant. So they want to have point to multipoint fiber drops to sort of go across a river, whatever the obstacle that makes fiber very challenging, and then use the existing wiring. And we have a daisy chain mode. Reg showed it briefly. We can create kind of a hub and spoke piece. So you can go into a new development area, drop your whatever fixed wire, whatever broadband access gigabit feed that you have, and then we can have a first GAM connect to another GAM that then serve households. So it's not just a GAM going to an household the way a traditional DSLAM does or a OLT does, because G.hn is homogeneous in terms of the technology, whether you're at one end or the other of the link. We have this daisy chain capability that allows us to be creative in reusing existing infrastructure, both as a transport and as an access network. So it gives you lots of options when you try to go into a new neighborhood where you don't want to go immediately with a massive build out. You can go with a single drop if you're doing fixed wireless, do a first drop, get customers connected, and then over time you may overbuild with whatever you can get ready for fiber, but that's 2 years out, or you can have a bit more of a mesh infrastructure, for instance, to provide redundancy and provide initial coverage. But we can get you going very quickly with good bandwidth, and that's to replace cases where the only alternative would be a remote DSLAM that can push maybe 25 meg down to a customer, and that's it, and only 3 meg up, which nowadays is no longer enough. So we're not limited to RDOF, but when you have RDOF money, we can help you get the most out of the subsidies that you'll be receiving.
Anybody else? Sounds like no. So why don't we do this? Why don't we go ahead and adjourn, and then plan to circle back after we've had a chance to talk. But I do want to thank the folks from Positron for being able to provide this presentation and answer any questions that we have. And with that, I don't know if you all had any final remarks before we go ahead and adjourn.
We can send you documentation. We can send you presentations, published magazine articles, customer cases, but data sheets, like whatever you want. We can send
and
it.
we have a try and buy program. So either Reg or Peter, who's turned off his camera now, but we can help you with getting trial units for your lab, or if you want to go into a friendly live deployment, depending on whatever capabilities you have. We can help you do this, because although it's a technology that's been around for a while, it's a new solution for a lot of people, and people nod their heads and say, yeah, you get a fantastic story, now show me. So we're more than ready to put our money where our mouth is and help you get up and running, and then kick the tires and really get to appreciate for yourself how well it works into your network.
Great. Anything else? All right.
Hey, Brett, I just want to make sure, I know this is recorded. Would there be a chance will we get a copy of the recording?
Not to ask.
Yes, I'll share a copy of the recording and also the slides.
Great, thank you.
Well, one other question. I guess you would mostly be using copper pairs, or you also use coax?
Any folks want to comment on that one?
A DFN would primarily be copper pairs.
Okay, and well, that's good. And you can feel free to ask any questions, come back. We'll send you data, and you're welcome to try units in labs or in the field, inside units, outdoor units, whatever. And that's where we really shine, because a lot of people find it hard to believe the performance figures, but they're there and they're rock solid.
Okay, thank you for the presentation.
Thank you for your attendance.
Thank you for your time. So we'll share all this with you by email. No problem.
All right.
Thank you very much.
Well,
Thanks, everybody.
I'd like to thank you very much for setting this up, and we're quite prepared to expand on this, and also to provide more presentations and more and go into more depth in any areas, and anyone who wants to get a presentation or information or assistance with it, we're available.
Great. No, appreciate that. Thank you so much.
Thank you. Bye-bye.
Thanks, everyone.
Thank you.